What if I told you that 1,000 years ago, a group of people living in one of the harshest climates on Earth built homes so energy efficient that many modern houses still can't compete with them? Imagine standing outside during a Scandinavian winter. The wind is screaming across frozen ground. Snow drifts pile higher than a man. Temperatures plunge so low that exposed skin can become dangerous within minutes. Common sense says you build bigger fires, thicker walls, taller structures. Vikings chose a completely different solution. Instead of reaching toward the sky like medieval castles and cathedrals, they dug into the earth itself. To outsiders, their homes looked strange, almost primitive. Grass-covered mounds scattered across the landscape. From a distance, they barely looked like buildings at all. For generations, historians assumed these structures were simply the best Vikings could manage with limited resources. But modern research has forced experts to reconsider that assumption. What if these homes weren't signs of technological limitation? What if they were evidence of technological brilliance? Because hidden beneath those grassy hills was something extraordinary. A sophisticated environmental system that solved problems of heating, food preservation, defense, sustainability, and community design centuries before modern science could explain why it worked. The more archaeologists study Viking turf houses, the more uncomfortable the comparison becomes for modern architecture. Today we spend billions of dollars trying to reduce energy consumption. We install advanced insulation, computerized climate control systems, and expensive sustainable building materials. Meanwhile, Viking farmers armed with little more than shovels, axes, and generations of practical experience were achieving results that would impress contemporary engineers. And here's the truly fascinating part. They weren't trying to save the planet. They weren't pursuing environmental ideals. They weren't participating in a sustainability movement. They were simply trying to survive. History often teaches the same lesson in different forms. Necessity is the most demanding teacher humanity has ever known. When survival is at stake, innovation becomes mandatory. Every mistake carries consequences. Every improvement matters. The Vikings lived in a world where poor design could mean freezing to death before spring arrived. That kind of pressure creates a very different relationship with technology. Nothing was built because it looked impressive. Everything was built because it worked. And that raises a question worth asking. Have modern societies become so obsessed with complexity that we've forgotten the power of simple solutions? Because the story you're about to hear isn't really about Viking houses. It's about human ingenuity. It's about how ordinary people confronted extraordinary challenges and discovered principles that remain surprisingly relevant 1,000 years later. Most importantly, it's about why some of the smartest ideas in history were buried underground, hidden beneath grass, waiting centuries for the rest of the world to catch up. The secret of Viking survival began with a simple observation that most people never think about. Walk outside during winter and the air temperature might be 20 below zero. Dig a few feet into the ground and suddenly the world changes. The temperature becomes remarkably stable, not warm exactly but steady. Predictable, reliable. The Earth itself acts like a giant thermal battery. Today we explain this using soil thermodynamics and geothermal principles. Vikings didn't have scientific textbooks. They had something arguably more valuable, generations of accumulated experience. Somewhere in the distant past, someone noticed that underground storage pits stayed warmer than the surrounding air during winter. Someone noticed that animals often sheltered in burrows during storms. Someone noticed that snow melted differently above certain patches of ground. Over centuries, those observations evolved into one of the most effective housing systems ever developed for cold climates. The genius wasn't simply building underground. Many cultures have done that throughout history. The genius was understanding exactly how much underground. Viking builders rarely buried their homes completely. Instead, they partially sank structures into hillsides, allowing the earth to provide insulation while still maintaining access to sunlight, ventilation, and living space. It's the kind of balanced solution that often emerges when people solve problems through generations of trial and error. Modern engineering tends to admire elegant compromises, and Viking turf houses were full of them. Think about what happens inside a modern home during winter. Heat constantly escapes through walls, roofs, windows, and floors. That's why heating systems work so hard. They aren't just creating warmth. They're fighting loss. Viking builders attacked the problem from a different angle. Instead of generating more heat, they focused on preventing heat from escaping in the first place. Thick turf walls, sometimes reaching 6 feet in thickness, formed an insulating barrier that trapped warmth inside. Modern insulation ratings suggest some of these walls performed better than many contemporary residential buildings. That's an astonishing thought. A farmer in medieval Iceland using dirt, grass roots, and practical knowledge may have built a more thermally efficient structure than countless homes standing today. But efficiency wasn't merely about comfort. Firewood represented labor. Every tree cut required effort. Every log burned had to be replaced. In regions where timber was scarce, wasting fuel could become a survival issue. A house that needed half the firewood wasn't just convenient, it was transformative. Suddenly, families spent less time gathering fuel. Resources stretched further through winter. Communities became more resilient. This is one reason I find ancient engineering so fascinating. The solutions often appear simple until you examine their consequences. A better wall doesn't just create a warmer room. It changes economics. It changes labor patterns. It changes survival rates. It changes entire ways of life. And the Vikings were only getting started. Because warmth was valuable, but in their dangerous world, another challenge demanded equal attention. Staying alive required more than protection from the weather. Sometimes it required protection from other people. If Viking turf houses had only solved the problem of cold weather, they would still deserve a place among history's great engineering achievements. But survival in medieval Scandinavia involved another danger that modern people often underestimate: visibility. Today we associate homes with being seen. We want houses that stand out. Large windows, impressive facades, bright exterior lighting. A Viking approaching the problem from a survival perspective reached the exact opposite conclusion. If enemies can find you easily, you've already made a mistake. Popular culture often portrays Vikings exclusively as raiders arriving unexpectedly on foreign shores. The reality was more complicated. Viking communities existed in a world of constant uncertainty. Rival clans competed for resources. Feuds lasted generations. Coastal settlements faced threats from both local rivals and distant enemies. In such an environment, visibility became a liability. This is where turf architecture transformed from housing into camouflage. Within weeks of construction, grass began growing across roofs and walls. Wildflowers appeared. Moss spread naturally. What had started as a building slowly merged with the landscape itself. From a distance, many homes became almost indistinguishable from the hills surrounding them. Imagine sailing along a rugged coastline searching for a settlement. You're expecting wooden buildings, smoke columns, signs of human activity. Instead you see rolling green terrain, maybe a few unusual mounds, nothing obvious. Meanwhile, an entire community could be living beneath those grassy shapes. The more you think about it, the more remarkable it becomes. Modern militaries spend enormous resources developing camouflage technologies. The Vikings accomplished something similar using dirt and grass. Not because they were trying to be clever for its own sake, but because nature provided the perfect disguise. And here's what fascinates me most. Their camouflage actually improved over time. Most defensive systems deteriorate. Walls crack, paint fades, structures weaken. Viking turf houses became more difficult to detect as vegetation matured. Nature wasn't attacking the building. Nature was helping hide it, but concealment created another challenge. Even the most hidden house becomes obvious if smoke rises from the roof every evening. Cooking fires and heating fires produce signals visible for miles. Once again, Viking builders responded with practical ingenuity. Instead of allowing smoke to rise directly upward in a clear column, they developed systems that dispersed it more gradually. Smoke drifted through vents and passages, spreading across larger areas and blending with fog, mist, and changing weather conditions. The goal wasn't invisibility. The goal was ambiguity. That's a surprisingly sophisticated distinction. Great defensive design doesn't always eliminate evidence. Sometimes it simply makes evidence difficult to interpret. Looking back, these houses reveal something deeper about Viking society. They weren't merely building shelters. They were designing environments that worked with the landscape instead of against it. Modern architecture often begins by asking, how do we change this location to suit our building? Viking architecture frequently asked the opposite question. How do we shape our building to suit this location? That mindset appears again and again throughout their construction methods. The earth provided insulation. The terrain provided drainage. The vegetation provided concealment. The wind provided information about placement. Every natural element became part of the design. And perhaps nowhere was that partnership between humans and nature more impressive than in the way Vikings solved one of humanity's oldest problems, keeping food alive long enough to keep people alive. One of the greatest fears in the medieval world wasn't invasion. It wasn't war. It wasn't even winter. It was hunger. A modern person can drive to a supermarket and choose from thousands of food items regardless of season. Vikings lived in a reality where one failed harvest, one extended storm, or one unusually harsh winter could threaten an entire community. In that world, storing food wasn't a household chore. It was a life support system. And this is where Viking turf houses begin to look less like homes and more like carefully engineered survival machines. The same underground environment that trapped heat also created something extraordinary, naturally stable temperatures. Modern refrigeration depends on electricity, compressors, chemicals, and complex mechanical systems. Vikings achieved a similar result using physics. Dig deep enough and temperatures remain remarkably consistent throughout the year. Cool during summer. Above freezing during winter. Perfect conditions for preservation. Imagine opening a hidden chamber beneath your home and finding months of stored food protected from temperature extremes outside. Butter, cheese, dried fish, smoked meats, fermented foods, supplies carefully accumulated during productive seasons and preserved for the difficult months ahead. This wasn't merely storage. It was time travel. Vikings were effectively transporting calories from one season into another. Every preserved fish represented a future meal. Every wheel of cheese represented security. Every barrel of food represented one more step away from starvation. What fascinates me is how much of human civilization depends on this ability. Agriculture produces food. Storage transforms food into stability. Without storage, abundance becomes temporary. With storage, abundance becomes resilience. Viking builders understood this instinctively. Entire sections of their homes were dedicated to maintaining ideal preservation conditions. The underground chambers weren't accidents. They were critical infrastructure. And unlike modern refrigerators, they never broke because of power outages. They never required fuel. They never generated monthly expenses. The earth performed the work continuously and for free. Modern sustainability experts often discuss passive systems, designs that accomplish goals without consuming additional energy. Viking food storage may be one of history's most successful passive technologies. It solved a deadly problem using nothing but intelligent placement and natural conditions. Yet there is another lesson hidden here. The Vikings weren't trying to dominate nature. They were collaborating with it. That's a distinction modern societies sometimes forget. We often approach environmental challenges by asking how technology can overpower limitations. Vikings frequently asked how natural systems could be recruited as allies. The soil became insulation. The landscape became camouflage. Underground temperatures became refrigeration. Every successful solution reduced dependence on scarce resources. Every improvement increased resilience. And resilience mattered because Viking settlements existed in places where resources were often limited. In Iceland, Greenland, and other northern territories, survival depended on solving a problem that would challenge even the most skilled builders. How do you construct entire communities when one of the most important building materials in the world is almost impossible to find? Scarcity has a strange effect on human creativity. give people unlimited resources and they often become wasteful without realizing it. Take those resources away and suddenly every material acquires value. Few places demonstrate this principle better than Viking settlements in Iceland and Greenland. When many people picture Viking construction, they imagine endless northern forests supplying limitless timber. Reality was far less generous. In large portions of the North Atlantic world, good construction wood was scarce, precious, and sometimes worth more than people today would consider reasonable. Imagine trying to build an entire community while treating every usable log the way a modern family might treat a luxury appliance. That's the challenge many Viking builders faced. Timber wasn't simply a building material. It was strategic infrastructure. Ships required it, tools required it, furniture required it, fuel required it. Waste was not an option. This forced Viking communities into a fascinating exercise in resource prioritization. They began asking a question that modern societies rarely have to ask. What is the absolute minimum amount of wood required to build a functional structure? The answer transformed architecture. Instead of constructing massive wooden walls, Vikings used the material that existed in overwhelming abundance, earth itself. Turf wasn't glamorous. It wasn't prestigious, but it was available. More importantly, it regenerated. Cut turf from a meadow, and given enough time, nature would rebuild the resource. Compare that to a mature tree that might require decades or even centuries to replace. Suddenly dirt begins looking surprisingly sophisticated. What fascinates me is that scarcity didn't merely force Vikings to accept turf construction. It pushed them to master it. Human beings often become experts in whatever they cannot afford to waste. Because every turf block mattered, cutting techniques became highly specialized. Because every timber beam mattered, structural designs became highly efficient. Because every construction season mattered, entire communities coordinated labor with remarkable precision. This is one reason ancient technologies are frequently underestimated. We tend to evaluate them by the simplicity of their tools rather than the sophistication of their knowledge. A Viking builder may not have possessed modern machinery, but he likely understood local soils, weather patterns, drainage conditions, structural loads, and material behavior with extraordinary depth. Not through textbooks, but through generations of accumulated observation. Knowledge doesn't become less impressive simply because it isn't written down. In many ways, it becomes more impressive. Somewhere in the Viking world, people learned which grasses produced stronger turf blocks. They learned when roots were strongest. They learned how moisture affected durability. They learned which slopes provided the best construction sites. These discoveries weren't theoretical. Mistakes carried consequences. Poor choices could leave families exposed to weather, hunger, or structural failure, and that pressure refined expertise. Yet all of these achievements led to a daunting engineering challenge. Building with earth sounds simple until you remember that earth is heavy, extremely heavy. A turf roof large enough to protect a family could weigh tens of thousands of pounds. That's not a roof. That's an artificial hillside balanced above your head. Keeping that weight from collapsing required an engineering solution so effective that modern structural designers still admire its logic today. The moment you hear that a Viking turf roof could weigh as much as several modern pickup trucks, the obvious question becomes, why didn't the entire structure collapse? Because gravity is relentless. It doesn't care about ingenuity, optimism, or tradition. If you place 20,000 pounds of earth above a room, gravity demands a serious explanation. The Vikings responded with one of the most impressive examples of practical engineering in the medieval world. What's remarkable isn't that they solved the problem. Human beings solve structural problems all the time. What's remarkable is that they solved it without advanced mathematics, computer modeling, or modern engineering software. They solved it through observation, experimentation, failure, and adaptation. Generations of builders slowly learned how weight behaves. They learned where structures crack. They learned which beams fail first. They learned how pressure travels through a building. Over centuries, these lessons evolved into construction systems sophisticated enough to support entire hillsides resting on rooftops. At the heart of many turf houses stood an internal timber framework designed not merely to hold the roof up, but to distribute its immense weight. Modern engineers call this load distribution. Vikings simply called it survival. Instead of concentrating pressure onto a few points, they spread it across numerous supports. Every beam shared responsibility. Every support reduced stress elsewhere. It was less like holding up a roof and more like teaching the entire building to cooperate. And cooperation became even more important because weight wasn't the only enemy. Water was equally dangerous. In Iceland, rain can fall for days, sometimes weeks. Moisture slowly destroys poorly designed structures. Wood rots, walls weaken, foundations shift. Modern homeowners know how expensive water damage can be. Vikings knew it could be fatal. Their solution reveals an extraordinary understanding of natural materials. Between layers of turf, builders placed sheets of birch bark. To modern eyes, it seems almost too simple. Yet birch bark possesses remarkable waterproofing qualities. Properly installed, it creates a barrier that channels water away while allowing the structure beneath to remain protected. No synthetic membranes, no chemical treatments, no industrial manufacturing. Just a material harvested from nature and used with remarkable intelligence. This is where I think modern people sometimes misunderstand historical innovation. We assume technological progress always means adding complexity. Yet many of history's greatest solutions reduced complexity instead. Viking builders weren't asking, "What can we add?" They were asking, "What already exists that solves this problem?" The answer was often hiding in plain sight. Birch bark solved waterproofing. Turf solved insulation. Earth solved temperature control. Hillsides solved drainage. Nature provided the components. Human ingenuity assembled them into a system. And perhaps the most astonishing part is what happened after construction ended. Most buildings begin deteriorating immediately. Viking turf roofs often became stronger. Grass roots continued growing. Vegetation expanded. The roof literally reinforced itself over time. Imagine building a house today that improves itself year after year. It sounds futuristic. For the Vikings, it was simply another practical consequence of working with nature instead of against it. But even the strongest roof and the warmest walls would mean little if Arctic winds could still invade the interior. And those winds forced Viking builders to master something modern architects still obsess over today: controlling airflow. Modern architects spend enormous amounts of time thinking about airflow, insulation gaps, heat loss, and energy efficiency. Entire industries exist to solve these problems. Yet 1,000 years ago, Viking builders were confronting the same challenges with a much simpler question. How do you stop winter from entering your house? It sounds obvious, but in northern climates, controlling air movement can matter as much as generating heat. A room doesn't become cold merely because the outside temperature drops. It becomes cold because warm air escapes and cold air replaces it. Vikings understood this intuitively. Every gust of Arctic wind represented stolen warmth, stolen comfort, and stolen fuel. That meant every doorway, hallway, and opening became a critical engineering decision. One of the most fascinating features of Viking turf houses is how deliberately inconvenient they appear. Modern homeowners generally prefer large entrances, open floor plans, and spacious transitions between rooms. Vikings often preferred the opposite. Their doorways were intentionally small. Visitors frequently had to duck to enter. At first glance, this looks primitive. In reality, it was remarkably intelligent. Smaller openings reduce heat loss. Smaller openings reduce wind penetration. Smaller openings are easier to defend. One design choice solved multiple problems simultaneously. That's a recurring theme in Viking architecture. Every feature performed more than one job. The entrance tunnels provide an even better example. Rather than creating a direct path from outdoors to indoors, many homes forced visitors through a narrow, curved passage. To modern eyes, it might seem awkward. To a Viking family, it was a thermal shield. Wind rushing toward the house would hit the curve, lose momentum, and dissipate before reaching the living space. In effect, the architecture itself acted like a natural airlock. Long before modern engineers discussed airflow management, Viking builders were manipulating air movement using geometry. And then there was orientation. Few aspects of construction reveal Viking intelligence more clearly than site positioning. These people paid obsessive attention to wind direction. Generations of observation taught them which storms arrived from which directions. They knew where snow accumulated. They knew where sunlight lingered longest. A poorly positioned house would struggle for decades. A properly positioned house could serve a family for centuries. Think about that level of patience. Today, we often build structures expecting them to last a few decades before renovation or replacement. Vikings frequently made decisions with future generations in mind. The placement of a doorway wasn't merely today's problem. It was a decision that might affect children, grandchildren, and great-grandchildren. That perspective changes how people think about design. What fascinates me most is how much of this knowledge came from direct observation rather than formal science. Vikings didn't possess meteorological models. They possessed memory. They watched storms. They watched snowdrifts. They watched sunlight move across landscapes, year after year, generation after generation. Eventually, those observations accumulated into a sophisticated understanding of environmental behavior. This reminds us that expertise doesn't always emerge from laboratories. Sometimes it emerges from paying close attention for a very long time, and that accumulated wisdom allowed Viking houses to achieve something remarkable. They weren't just shelters. They were living environments carefully tuned to the realities of the landscape around them. But perhaps the most impressive feature wasn't how these homes protected people from nature. It was how they helped people stay connected to each other through some of the longest and darkest winters on Earth. One of the biggest misconceptions about Viking life is the idea that every family lived in isolated cabins scattered across frozen wilderness. It's a compelling image, but archaeology tells a far more interesting story. Viking turf houses weren't simply buildings. They were social machines. They were designed to hold communities together in environments where isolation could be as dangerous as hunger. Imagine 6 months of winter darkness. Imagine storms that make travel impossible. Imagine temperatures cold enough to turn even short outdoor trips into calculated risks. Under those conditions, human relationships become infrastructure. Family isn't merely emotional support. Family becomes survival technology. And Viking homes reflected that reality in fascinating ways. Unlike many modern houses, which are often designed around privacy and individual space, Viking homes prioritized connection. As families expanded, homes expanded with them. A young couple might begin with a modest structure, just enough room for sleeping, cooking, and storage. Years later, new chambers could be added. Children grew. Grandparents moved in. Relatives joined the household. Rooms multiplied. Passageways extended. Entire generations became physically connected beneath a shared roof system. Some archaeological sites reveal houses evolving over centuries, growing from small dwellings into sprawling underground complexes. What fascinates me is how different this mindset feels compared to modern housing culture. Today, independence is often considered the ultimate goal. Success frequently means having more personal space, more separation, more privacy. Viking communities operated according to a different logic. In harsh environments, proximity created resilience. Knowledge passed more easily between generations. Childcare became a shared responsibility. Elderly family members remained integrated into daily life rather than isolated from it. Skills, stories, traditions, and practical wisdom flowed continuously through the household. And there was another advantage that modern architects increasingly recognize. Shared living reduces resource consumption. One large, efficiently heated structure often requires fewer resources than multiple separate buildings. Viking communities weren't conducting sustainability experiments. They were simply responding rationally to environmental realities. Yet many of their solutions now resemble concepts promoted by contemporary urban planners and environmental designers. Multi-generational housing, shared resources, flexible living spaces, community-centered design. These ideas are often presented as innovations today. The Vikings might have recognized them as common sense. The internal layout of these homes reveals even deeper levels of practicality. Warmest areas near the central hearth were often reserved for those most vulnerable to cold, including older family members. Younger adults frequently occupied outer sections where temperatures fluctuated more. Space allocation wasn't determined by status alone. It was influenced by physical need. In other words, architecture itself became part of the community's support system. Every room reflected a survival calculation. Every expansion reflected changing family dynamics. Every passageway represented adaptation. And perhaps that's the most impressive aspect of these homes. They weren't static. They evolved. Unlike rigid architectural plans imposed from above, Viking turf houses behaved more like living organisms. They grew, adjusted, and responded to changing circumstances. That flexibility may explain why some settlements remained occupied for centuries. The buildings weren't simply resisting change. They were designed to absorb it. Yet even the most adaptable home depended on one critical factor. Before a single turf block could be cut, before a single beam could be raised, Vikings had to answer a question that determined everything that followed. Where exactly should the house be built? If there is one moment where Viking architecture begins to resemble modern science, it is the process of choosing where to build. Most people imagine ancient builders simply finding an empty patch of land and starting construction. The Vikings approached the problem with far more sophistication. In many ways, site selection was the most important engineering decision they would ever make. Get it right, and generations could thrive. Get it wrong, and every problem became harder forever. What fascinates me is that Vikings treated the landscape almost like a conversation partner. They weren't asking, "How do we force a house onto this land?" They were asking, "What is this land trying to tell us?" Modern geologists, hydrologists, and environmental engineers use technical instruments to evaluate soil conditions, drainage patterns, and environmental risks. Viking builders relied on observation, experience, and inherited knowledge. Yet they often arrived at remarkably similar conclusions. South-facing slopes were prized because they captured precious sunlight during long northern winters. A few extra hours of solar exposure each day could make a meaningful difference in comfort and fuel consumption. Today, we call this passive solar design. Vikings simply called it common sense. The slope itself mattered too. Too flat and rainwater accumulated around foundations. Too steep and structural stability became a concern. Somewhere in between lay the sweet spot, a location where gravity worked for you instead of against you. This is something modern engineering repeatedly rediscovers. The best designs don't fight natural forces, they recruit them. A properly chosen hillside could provide drainage, insulation, concealment, wind protection, and solar exposure simultaneously. That's an extraordinary return on a single decision. Then came soil testing. And yes, Vikings effectively performed soil tests. They may not have used laboratory equipment, but experienced builders understood that not all ground behaved the same. Clay-rich soils often held their shape well and provided stable support. Loose sandy soils created risks. Waterlogged areas invited future disaster. Every shovel of dirt revealed information. Every successful structure contributed new lessons to the collective memory of the community. Looking at this process, I'm struck by how much patience it required. Modern societies often celebrate speed, faster construction, faster approvals, faster results. Vikings invested heavily in understanding a site before committing resources. In a world where mistakes could last generations, patience became a form of intelligence. And then there was defense. The ideal location wasn't merely comfortable, it was strategic. Families wanted visibility across surrounding landscapes. They wanted advance warning of approaching riders or ships. They wanted enough distance from flood zones without becoming isolated from water sources. Every factor influenced every other factor. The result was a kind of environmental systems thinking that feels surprisingly modern. Nothing existed in isolation. Climate influenced construction. Construction influenced survival. Survival influenced settlement patterns. Settlement patterns influenced social organization. Everything connected. Perhaps that's why some Viking farmsteads remained occupied for centuries. The builders weren't selecting locations randomly. They were identifying places where multiple natural advantages converged. Once discovered, those locations became extraordinarily valuable. Generations inherited not merely land, but accumulated wisdom about how to live successfully on that land. And once the perfect site had been chosen, the real challenge began. Because identifying the ideal location was only the first step. Transforming a hillside into a functioning home required thousands upon thousands of carefully crafted turf blocks, and a level of craftsmanship that most modern people would find astonishing. By the time the first turf block was cut, most of the important decisions had already been made. The location was chosen. The orientation was planned. The family knew where future rooms might eventually expand. What remained was the physical labor, and there was a lot of it. Modern construction often relies on machines capable of moving enormous amounts of material in hours. Vikings relied on human strength, community cooperation, and techniques refined across generations. Yet despite the lack of machinery, what they accomplished remains genuinely impressive. A single family-sized turf house could require thousands of individual blocks, not rough chunks hacked from the ground, but carefully shaped sections cut to specific dimensions. Too large and they became impossible to transport efficiently. Too small and structural stability suffered. This wasn't random digging. It was precision work disguised as manual labor. What fascinates me is how knowledge became the most valuable construction tool. Experienced turf cutters knew exactly where to place a blade. They knew which meadows produced the strongest blocks. They knew how moisture levels affected durability. They knew how to stack materials so weight compressed the structure rather than weakening it. Much of this expertise never appeared in written manuals. It lived inside people. Parents taught children. Skilled workers taught apprentices. Communities preserved techniques through repetition. In many ways, Viking architecture reminds us that technology is not merely machines. Technology is knowledge applied to solve problems. And by that definition, Viking turf houses were highly advanced technology. The walls themselves reveal remarkable sophistication. Builders often arranged blocks in interlocking patterns designed to prevent vertical weaknesses. Instead of creating continuous seams where cracks could spread, they staggered layers much like modern brickwork. Stone foundations elevated the walls above wet ground. Moss and loose soil filled tiny gaps. Every detail served a purpose. Every improvement represented lessons learned from previous successes and failures. Looking at these structures, I am constantly reminded of something modern societies occasionally forget. Durability is a form of intelligence. Today, many products are designed around replacement cycles. Build, use, replace, repeat. Viking builders operated according to a different philosophy. They expected homes to survive decades, sometimes centuries. Maintenance was part of life, but complete replacement was not the goal. This long-term mindset changed everything. Decisions were evaluated not merely by today's convenience, but by tomorrow's consequences. And perhaps nowhere is that philosophy more visible than in the roof. Layer upon layer worked together to create a living system. Timber provided structure. Birch bark provided waterproofing. Turf provided insulation. Grass roots strengthened the entire assembly over time. The roof wasn't simply covering the house. It was participating in the house, growing, adapting, improving. That's a concept that feels almost futuristic despite being more than 1,000 years old. When we step back and examine the entire system, the achievement becomes impossible to ignore. Viking turf houses combined passive heating, natural refrigeration, camouflage, storm resistance, resource efficiency, multi-generational living, sustainable materials, environmental adaptation, and long-term durability into a single design. Modern architecture often treats these as separate challenges requiring separate technologies. Vikings solved them through integration. Takeaway: The greatest lesson of Viking turf houses is not that ancient people were smarter than modern people. It is that they were forced to think differently. They lived close enough to environmental realities that every design decision carried immediate consequences. Instead of fighting nature, they studied it. Instead of consuming endless resources, they maximized the value of available ones. Instead of building monuments to themselves, they built systems that worked. 1,000 years later, as we search for more sustainable ways to live, perhaps the most surprising discovery is that some of the answers were hiding beneath the grass all along.